Here we have two more examples of using the binomial distribution when you're needing the calculator to add values together for you. A company purchases shipments of machine components and uses this acceptance sampling plan. Randomly select and test 27 components and accept the whole batch if there are fewer than 3 defectives. If a particular shipment of thousands of components actually has a 7% rate of defects, what is the probability that this whole shipment will be accepted? So, let's think about what information are we given. We're given that they test 27 components, so that's our N, or our number of trials. And it says that the components have a 7% rate of defects. So that would be our P. And instead of writing 7%, we're going to write that as a decimal, so that would be 0.07. Now we're going to have to figure out what X values we're looking for. So let's think about that for a second. They want to know what's the probability that the shipment is accepted. So write that down. Probability of accepted. And if we have the probability of accepted, it said that it was accepted when we had fewer than 3 defectives. So that's the probability of fewer than 3. Well, if we are fewer than 3, 3 is not included. So X is less than 3. X is less than 3. It's going to include 2, 1, and 0. So this is going to be equal to the probability that X is less than 3. In order to find that, we can use our binom CDF function, and I showed you in the previous video how to go to the calculator and enter that on the first example in the previous video. We're going to use the cumulative function, so make sure you choose the binom CDF, not PDF. We want to enter 27 for our number of trials. We're going to enter 0.07 for our probability value. And then, here's the tricky part. 3 is not included in the values that we want the calculator to add for us. So we have to stop it at 2. We're going to stop it at the next lowest whole number. So this means the calculator is going to add the probability of 0 plus the probability of 1 plus the probability of 2. And that's what we need. We need fewer than 3. So 0, 1, and 2. So run that on your calculator and you should get 0.708. This problem is one of those that you really have to think about what they are asking, because the wording can be a little bit confusing. That's why I started with writing down the probability of accepted. That's what they were looking for. And then I had to decide, what did that mean? Well, they tell us for it to be accepted, it needs fewer than 3 defects. So then from there I could translate exactly what they're wanting from this problem. Next example. A test consists of 10 true-false questions. To pass the test, a student must answer at least 6 questions correctly. If a student guesses on each question, what is the probability that the student will pass the test? So again, let's write down our N, our P, and our X. N is 10, our number of trials, 10 questions, 10 trials. These are true-false questions, so the probability of answering one correct is 0.5. Then, let's look at what our X should be. They want to know what's the probability that the student will pass. Well, it tells us they pass if they get at least 6 correct. At least 6 means 6 or more. So we're going to have greater than or equal to 6. So we want the probability that they pass. That's the probability that they get 6 or more correct. Now, this is one of the problems where we need to add up to get the answer. We need the values of 6, 7, 8, 9, and 10, the probability of each one of those. However, the calculator won't do that for us because it will only add up the values 0 through 1, 2, 3, 4, 5, etc. So in order to get the values for 6, 7, 8, 9, and 10, we need to subtract the values less than that from 1. So 1 minus binom CDF, number of trials, 10, probability is 0.5, and then since we want 6 to be included, and I know that we want 6 included because 6 is part of our inequality because of the equal sign. We want it to be included in our answer, our final answer. We don't want it to be included in this binom CDF. We want anything less than that to be subtracted out. So 10.5, and then we're going to stop at 5. So we run that on our calculator. 1 minus binom CDF, 10.55. And this is equal to 0.377. And again, you can put into your calculator 1 minus and then go to the binom CDF menu and have it subtract that for you without having to write down what you get from the binom CDF. If you have any questions at all, please contact me. There is an alternative method that we can discuss if this method is not helping. So let me know, email, come see me, something so I can help you.